Let's have a look at answering the remaining questions of this paper. So, at time t equals 0 hours, a tank is full of water. Water leaks from the tank. At the end of every hour, there is 2% less water in the tank than at the start of the hour. The volume of water in litres in the tank at time t hours is Vt. So given that V0 is 2000, so that's what it starts off with. To get the next value, we have to do K times Vt, so the one previous. So because there's 100%, isn't it, to start off with? There is 2% less, that means there's 98%. Now, K is your multiplier, the number you're going to times with. So to make something less by 98%, we need to know what that is as a decimal, and it's 0.98, and that is your answer. Looks quite tricky, sounds quite tricky, but it's actually not, and it's only worth 1 mark, and it's a lot of words there, a lot of unnecessary information really to try and trick you out, and especially because we're getting towards the end of the paper. Let's have a look at the next question, question 19. So this is worth 4 marks. We're getting towards the end of the paper, so a lot of words. So we've got a triangle has vertices P, Q, and R. Right, we've got the coordinates of P, the coordinates of Q, and the coordinates of R. And we've got M is the midpoint of PQ and N is the midpoint of QR. And we have to prove that MN is parallel to PR. Well, first of all, I would actually start off by drawing this. Right, so P is -3, -6, somewhere around there. Q is 1, 4. And 5 - 2, somewhere here. Okay, there we are. Kind of just label that as well, just so we can double check. Okay, so, right, M is the midpoint of PQ, and N is the midpoint of QR. Now we have to prove that MN is parallel to PR. Okay, so, can we work out the value of M? We can, can't we? Because M is the midpoint. So, I'm going to add the 2 coordinates up and half it. So add the 2x coordinates, -3 add 1 divided by 2, and -6 add 4 divided by 2. Well, that's -2 divided by 2, and that is -2 divided by 2. So the coordinate for M is -1, 1. Let's do the same for coordinate N. We're going to add the x's up and the y's up. So 5 add 1 divided by 2. -2 add 4 divided by 2, that's 6 divided by 2, and that's 2 divided by 2, so the coordinate for N is 3, 1. I can write that down, just going to get a different colour pen if it lets me. Okay, I'm going to write -1, 1, didn't work, did it? And 3, 1. Okay. So, we can now look at the gradient, can't we, of line MN. Because we've got the 2 coordinates, -1, 1, and 3, 1. Remember, the gradient is difference in y divided by difference of x. So x and y, I'm going to label that x, y, x, y. And that there is -1, isn't it? Just to double check, because -2 divided by 2, so I've made a bit of a mistake there. So I'm going to do 1 minus -1 over 3, take away 1. Well, that's 2 over 2, so the gradient is 1. Okay, is that right? X, no, it's not, is it? Because, see, always double check with this style of questions. Rush that just to add, and I've made this right thing at the top, but I've done the wrong thing there. So is 1 minus minus 1. X is 3, take away minus 1. That becomes 1 add 1, which is 2. That becomes 3 add 1, which is 4. So my gradient is actually half. So, okay, right, we've got that, or 2/4. You can leave it at any one of that. So, PR then. To know something is parallel, it has to be a multiple of each other. So we do know, the gradient of PR, because P is minus 3 minus 6 and R is 5 minus 2. And I'm going to do difference of Y. So I like to write X and Y just to make sure that I've got the right thing going on. So just take away that one from that one. Minus 2 minus minus 6. 5 minus minus 3. That becomes add minus 2, add 6 is 4. And 5 and 3 is 8. That is also a half. And they are a multiple of each other. Therefore, I'm going to say that they are the same, aren't they? Yeah, and that's it. Yep, they're a multiple of each other. Therefore, parallel. Yeah, because that's a half and that's a half. What can you times 1 by to get the other one? You can just times it by 1. And therefore, we've ended up with the right answer. Yeah. Okay. We've done with that one. Let's have a look at the next question. So, question 20. We have got a sector of a circle. The radius is 10. It tells you BA is a tangent and BC is a tangent from the same point. So they're going to have to be the same. We've got the angle 120. We have to calculate the area of the shaded region. Right. So, right. Let's have a look. I don't really know anything about the top bit. That's also 10 because it's a radius, isn't it? So what can I do? Well, first of all, I can work out these angles because I can do 180, take away 120, which is 60, and half it, which is 30. So that's 30, and that's 30. Right, I can also work out this line here by using cosine rule, can't I? Which is going to be a squared equals b squared plus c squared minus 2bc cos a. And I want a squared, so I've got 10 squared plus 10 squared, take away 2 times 10 times 10 cos 120. You could tap all that into your calculator in one go if you want. But when you do, I get 200 take away 200 cos 120, because 10 squared is 100, and 2 times 10 times 10 is 200. Tap that into my calculator and I end up with 300. I've got to square root to work out what a is, and I get 10 root 3. I'm going to leave it as that because I don't want any rounding issues. So I actually get 17.320500808. Okay, so let's have a look then. We've worked out that bit, which is 10 root 3. I'm just going to write that down. And is there anything else that I can do? Yes, there is. Because I know that if I try and change the color of my pen and hope that it works. Try and change the color of my pen. Okay, that seems to be working. Okay, there we are. I know that a radius meets a tangent over there at 90 degrees, doesn't it? So if that's 90, the leftover bit has to be 60. So got a lot going on here. We've got a triangle here, haven't we? Because if you have a look there, you've got 60, 60. The leftover one must also be 60. So this top one here has to be 60. Right, I need to work out the shaded area. I can work out the area of this unshaded bit first, which is quite simple, which looks like this, doesn't it? Yeah, because I've got 120 there. I've got 10 and 10 there, and it's just area sector. So it's 120 over 360 times pi times 10 squared. Tap that into my calculator and I've got 100 pi over 3. I'm going to leave it in pi format, but if you do want to know what that is as a number, it's 104.7197551. Right, got that bit. I now need to somehow work out the other bit. So let's see what I can do. Can I work out the little top? Because that might help. So if I can kind of work out this little semicircle bit on here as well, that might be able to help me what that area there is. So do I know the distance of that line? I do, don't I? That there is 10 root 3. I mean, do I need to know that? Could just work out the area of the triangle and take it away from the full thing. Got a lot going on here. That's 120. That's 10 and 10. Right, area of a triangle is a bit different than the sector because it's a half AB sine C, isn't it? Let's just use that. So a half times 10 times 10 times sine 120. Right. That there is 43.30127019. Right, if I want the little bit here, which is that bit, I've got to do the full thing, which is 100 pi over 3, take away the bit that I've just worked out, which is 43.30127019. Take them away from each other, and I'm left with 61.41848491. Right. Quickest way now to do this is now that I have got the top bit here. That's an equilateral triangle, isn't it? Because each side is 60. So which way is it? Is this way. So 60, 60, 60. If that's 10 root 3, that's 10 root 3, and that's 10 root 3. So I can work out my area by doing a half AB sine C again. Zoom in. So a half times 10 root 3 times 10 root 3 times sine 60 on my calculator, and I end up with 129.9038106. Right, that's the whole thing. I can then take off this bit here, this little bit here, this little semicircle, to end up with what I've got. So that's that. Take off the semicircle, which is 61.41848491, and I end up with 68.48532569. What is that in what they want? 3 significant figures, 68.5. And there we are. You can see that some of the last few questions are quite tricky and need a lot more work. to finish these questions off. Right, let's have a look at some of the other questions. This one here, we've got 12 counters in a bag. There is an equal number of red, blue, and yellow counters. Okay. There are no other counters in the bag, and 3 counters are taken at random, and I've got to work out the probability. So I'm just going to say red, blue, yellow, and there's 12. So 12 divided by 3, that means there's 4 of each colour. So work out the probability of taking 3 red. Well, the first one's 4 out of 12 times 3 out of 11 times 2 out of 10. Top bit is 24 over 1,320, and you can simplify that to 1 over 55, not 155. And there you are. Simple, this one. Let's have a look at this one. The 3 counters are put back into the bag. Some more counters are now put into the bag. There is still an equal number of red counters, blue counters, and yellow counters in the bag. There are no counters of any other colours. 3 counters are taken at random. Okay, is it now less likely or equally likely or more likely that 3 counters will be red? You must show your answer. So 3 counters are put back into the bag. And you've got some more counters that are now being put in, but there's still an equal number of red, blue, and yellow counters. So we've got 12 counters at the start. After 3 more, no, so after 3, so there's 3, isn't there? So 3 more counters. So start off at the top, we had 4, 4, 4. If we've got another 3, that makes it red, blue, yellow as 5, 5, 5. Yeah? So considering that we've only got 5, to take a red counter would be 5 out of 15 times 4 out of 14 times 3 out of 13. If I do that, that's 60 over 2,731, which is 2 over 91. As a decimal, that's 0.021978, round that to 0.022. The 1 over 55 as a decimal is 0.01818. That's 0.018. Which one is more likely? This one. So more likely to get a red. And I'm just going to underline that to show our answer. Okay. The next question there, we've got functions f and g. F is 5x plus 3, g is ax plus b. Have to work out the value of a and b. So first thing is, it tells you the function of g. When I substitute 3 in, I should get a times 3 add b. That's 3a add b. Right. Then I need to have the inverse function of f. Y equals 5x plus 3. Y take away 3 divided by 5 is x. So my inverse function is actually x minus 3 over 5. Does it tell me? Oh, it's 33. So I've got to put 33 in there. 33 take away 3 is 30. 30 over 50 is 6. No, not 30 over 50. 30 over 5. Why have I put 50 there? There we are. Okay, so what's the next bit that it's asking us? It tells you g of 1 would be a times 1 add b, which is a add b. Right, simultaneous equations now, because I've got g3 is equal to 20. So I've got 3a add b equals 20. The next function, f33 equals g of 1. So a add b equals 6. because F33 is 6. Right, take those away. 2a equals 14, a equals 7. Right, b, I'm going to plug it in this. A add b equals 6. 7 add b equals 6. Well, b has to be minus 1. Pretty simple and straightforward. Next question, which is the last question of this paper. We've got a geometric sequence. That means to get from one term to another term, you have to multiply. So we've got 3 terms and we have to work out the value of x. So first term, square root x minus 1. Second term, 1. Third term, square root x add 1. Right, to work out the ratio, how do you get from one to another? I'm just going to divide these two. Square root x add 1 divided by 1. That's just square root x add 1. So that means you are timesing by square root x add 1 each time. Right, so if I do square root x take 1 times square root x add 1, I should end up with 1. Because if I times this by this, I should end up with this. Because remember, you are timesing each time. And that's our ratio. That means you are timesing by that each time to get to the next one. Just like this. 1 times this would give you this. Right, so let's expand the bracket. I should get x plus square root x. Take away square root x, take away 1 equals 1. That becomes x take 1 equals 1. So x equals 2. I've now got the 5th term. And I need to show that the 5th term is that. Right, the 4th term. I've got to do square root x add 1. But I've got to times it by square root x add 1. But I know what x is 2. So square root 2 add 1 times square root 2 add 1. That becomes square root 4, which is just 2. Add square root 2, add square root 2, add 1. That becomes 3 add 2 root 2. That's the 4th term. We'll times that by root 2 add 1 again. And then do with 3 root 2, add 3, add 4, add 2 root 2, which becomes 5 root 2, add 7. And they just want it the other way around. 5 root 2. And there we are. We have proved that the 5th term is 7 add 5 root 2. Thank you for watching.